In this video, let's learn how to simply use some rules in algebraic formulas in solving and simplifying this radical expression given to us. Now, to get started, I'm going to look at two good expressions. From this expression, we'll simplify 30 and then simplify 35. Now, for simplify 35, you'll come to see that 30 can be equal to 2 multiplied by 3 multiplied by 5, right? And our 35 can simply give us the value of a 5 multiplied by 7, right? So we can have 5 multiplied by 7. If you take the LCM of 30, we will have 2 times 3 times 5. Now let's see how we can insert that into the radical expression given to us. If we insert that, we're going to have this to be a full square root of 220 minus 2 multiplied by 3 multiplied by 5, right? And all will be multiplied by the square root of 5 multiplied by 7, which is 35. Great. Now, having gotten that, I can break up that square root to give me the total square root of 220, right? Minus 2 multiplied by 3 multiplied by 5 multiplied by the square root of 5, right? Multiplied by the square root of 7. That is permitted. Now, if I simplify this, I'm still going to regroup all this to give me the value of the square root, the total square root of 220 minus 2. This will be multiplied by 3 root 5, right? And this will be multiplied by 5 root 7, and all these will be regrouped that way. Now come to look at this expression very well. From that expression, we can be able to simplify this properly by substituting or evoking an algebraic expression. But before we do that, I want you to look at this algebraic expression, and we are going to compare this to that algebraic expression. And then let's take the square of this and the square of this. The square of this will give us 3 root 5, right? If we simplify that using the square root, 3 root 5 is going to give us all squared will be equal to 3 times 3 will give us 9 multiplied by the square root of 5 squared. And if we simplify this, this is going to give us 9 multiplied by square root of 5 times square root of 5 will give us 5, and this will be equal to 45, right? Now, if we look at the other square root, 5 root 7, if we take the square root of 5 root 7, we're going to have this to become 5 squared multiplied by the square root of 7. 7 root 7 will give us 7. And this is going to give me 25 multiplied by 7. And 25 multiplied by 7 is going to give me 175. Now come to look at that. Those two expressions will give me 175 and 45. If you sum these two, expressions, we're going to see that we'll arrive at 220. So what does that tell us? That 175 plus 45 can replace 220. Now, if we bring that into that expression will now give us the total square root of 175 plus 45, which is 220, right? Then we'll now look at minus 2 multiplied by 3 root 5, right? Multiplied by 5 root 7, multiply by this, and this will be equal to this. So from that expression, we have simply simplified that expression. Now let's compare that expression with an algebraic formula. If you are given the algebraic formula a minus b square, recall from the algebraic formula rule, this can be equal to a square plus b square, right, minus 2ab, right? So from that expression, let us isolate the value of our a. From that expression, you can see that the value of a is going to give us the value that gave us 175, right? And the value of our b will be the value that gave us 45. Now, which value gave us 175? That is 5 root 7 multiplied by root 7. So we're going to have that expression to be equal to, that expression will be equal to the square root of 175 plus 45, which is 3 root 5 minus 2, the value of a, which is 5 multiplied by root 7. If we arrange this properly, multiplied by the value of b, which is 3 root what? Root 5. And all these will be what? Will be in square root. Now from that expression, you have seen that the value of a is equal to 5 root 7 square, and that's what gave us 175, and our b is equal to 3 root 5 square, and that's what gave us 45. So if we compare it with this, you can see that that expression is properly arranged. We have the a square, the b square, then we have 2 multiplied by the a and the what? And the b. So if all this expression can be represented by this expression, so we can take that this minus this, that is a minus b square, can give us what? Can give us this whole expression. So that expression can now be equal to the square root of 5 root 7 square minus 3 root 5 all squared, right? And that expression will now give us the value of this to become the square root of 5 root 7 minus 3 root 5 all what? All squared. So square root will have to clear the square of this value, and so that expression is going to give us the value of root 5 root 7 minus 3 root 7. And from that expression, this remains the solution to that expression, because 5 root 7 is definitely greater than 3 root 7, which is the absolute solution to that expression given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics content. Thanks so much for watching, and bye bye for now.